Hi everyone, welcome to week 3. We continue our series on human performance, health and safety. Last week we talked more about lower level things to do with our reflexes and more immediate reactions to bad immersive design. This week we'll be talking a little bit more about higher level considerations at the psychological and human sociological level. Now, when I make the distinction between the two topics, higher level or lower level, I don't necessarily mean that one is more important than the other. I mean it from a hand-wavy neurosystems kind of standpoint. It's a little bit like Maslow's hierarchy, where the foundational things are at the very bottom, and the more higher level stuff we see at the top is something we achieve because of the foundational stuff that we depend on below. So everything is important from the bottom all the way up. If we remove some of it from anywhere, it all breaks down. It's like a building, and typically people visualize this as a pyramid. And from personal experience, you cannot cheat Maslow. Do not cheat Maslow, or your entire design will fail. Now, having said that, let's get into it. We'll be looking at 4 main subtopics today. We'll start with safety critical operations, where situational awareness and cognitive load management is important. Essentially, this is where accidents can happen if you're not paying correct attention. And we can induce this by overloading people with information or not giving them enough information. But essentially, it comes down to proper immersive design. That's what we're here for. And the next thing is we'll look at training for safety critical situations. So this is like aircraft pilot training. If we were to emphasize on the wrong thing and get people to develop bad habits, that could be very dangerous too. Next, we'll be looking at the various therapeutic applications that immersive design can be used in. Specifically, we'll be looking at exposure therapy and how people have used it for PTSD treatment. And after that, we'll go along the same line, but a little bit more waffly, and look at well-being type applications. And when I say waffly, I mean the methodology and the research around the interventions are a little bit less rigorous, but still no less important and still quite effective. So anyway, safety critical operations. What are safety critical operations? Well, they are activities where there are tons and tons of opportunity for accidents. And these accidents aren't just a kid peeing or pooping themselves. These are accidents that can actually injure or kill someone. So we'd be talking about situations where there would be heavy machinery involved, the work environment is hazardous, or medical emergencies. These particular points aren't necessarily mutually exclusive. Sometimes all 3 are present. So we better really be careful about our design. Now, in this slide, I've listed a bunch of stuff that could be considered as safety critical operations, like anything that involves forklifts, ground mass transit, like buses and trains. Those can crash because of the bad immersive design. But if you'll indulge me for a little bit, let's dig into aviation. Now, I'm a bit of an aviation enthusiast. About this time last year, I was able to land at Sydney Airport because we had no airplanes coming in, and they were asking student pilots to come in and land and give them something to do. Normally, Sydney Airport would just tell you to go away. Go back to Bankstown, noob. That's Bankstown Airport. Bankstown Airport is Sydney's training airport. Actually, I hope we have a chance to visit the ACE Training Centre. Actually, that's the Aero Crewing Excellence Training Centre in Bankstown. There's some really cool mixed reality simulations there, but we'll talk a little bit more about that in week 5. I hope we get to go there as a class for real. It's really, really cool. Anyway, let's get back to aviation. Now, having to land at Sydney Airport gave me a really good appreciation of how much work airline pilots actually need to go through. And considering that they would have, 300, 400, however many people that they'd have in the back, depending on them, and considering the fact that most of us here would have been one of those people sitting in the back, we know how much of a safety critical situation this is. So let's think about what a pilot would need to think about as they're trying to land at the Sydney airport. I'm going to simplify this a little bit because actually I don't remember all the different procedures. Don't worry, I wasn't flying solo. I had my instructor sitting right next to me, correcting me, telling me what to do next, and helping me out if it seemed like I was a bit overloaded with all the tasks. But one of the things you need to do is you need to report into Sydney Central, the air traffic control tower. But I think there's at least three of them. There'd be one kind of controlling the wider Sydney airspace, and you need to report to them before you actually get into the airspace. And there's another one that will be telling you how to land, like which runway are you supposed to land at, and then whether you're cleared to land and all that. And then once you've actually landed on the ground, you need to switch over to the ground tower where they tell you which way you can taxi. So now keep in mind that it's not just one channel. So for example, once you talk to approach, they'll tell you how to vector. They'll say, they'll tell you to stay west of Cronulla Station until instructed or something like that. And you need to stay on that frequency. But once they tell you to go ahead, you're ready to come in, they tell you what the next frequency is, and then you as the pilot will have to remember what that is, set your radio to that next frequency, and then talk to those people. And usually it's still the same people. Like they're all sitting in the same little room in the tower. But the reason why they separate these frequencies in busy airports like Sydney is because there'll be lots of different airplanes at different stages of the landing process, and if you just use one frequency, there's a risk that they might all be talking over each other, and we don't want that because you might miss an instruction and possibly collide with someone. I just wanted to give you a sense of how hectic the communication process is already. You don't necessarily need to know the actual details, but this is taking a lot of space, a lot of cognitive load in your mind already. Now, you need to add that to the cognitive load that's already being taken by you having to actually still fly the aeroplane at the same time. Now, if you were just cruising and you weren't in a busy airspace, like you don't care, you just set autopilot, set your height, set your heading, and it just flies itself. But you're coming in to land. So you need to make sure that there are no other airplanes that's close by you. If you're in a single engine student aircraft, that means looking out the window, seeing if there's anyone close by. You might be looking at that little iPad just to see if there's anything that shows up in the radar. Well, that system isn't quite radar, but the point is there's one thing that you need to keep monitoring. You've got to do your final checks. They put it into acronyms so you remember. One funny one I'd like to share is bumpfish. You go brakes, so it's undercarriage, mixture, fuel, instruments, switches, and harnesses, and I think also hatches. But yeah, it's like you need to be checking this, and then you need to be doing this all at the same time as listening out for the radio. You might possibly be communicating, and then also looking out for other traffic. Then you get told which runway you're supposed to land at, and then you line up for the runway. You start descending, you got to try and make sure that your approach is correct. You're not descending too fast or you're not descending too slow. You're checking your speed. So if you're coming in for a flaps down landing, you got to make sure that before you deploy your flaps, you're actually not flying too fast, because if you deploy your if you deploy your flaps while you're flying too fast, it might come off, and that's not good. But you got to make sure you don't wash out too much of that speed, because if you go too slow, you might go below the stall speed, and then your aeroplane will just drop out of the air because you don't have any lift anymore. So it's a stressful situation. So I'm not really trying to teach you how to fly, obviously. I'm just trying to give you an idea of what you need to keep aware of to actually keep operating this machine safely. And we need to maintain something called situational awareness. That's actually a technical term in psychology. All it is like, do you know what's actually happening? In layman's terms, that's like a very simple thing to do, right? But when we talk about operating heavy machinery like an aircraft, this isn't as simple. There's a lot more things you need to worry about all at the same time. Unfortunately, every new thing that you need to keep track of and manage actually costs you some cognitive load. And when you have too much cognitive load, you just end up being overloaded and you can't do anything. Every parallel task that you're doing at the moment will just fail and you die. Now let's move a little bit away from the specific aircraft example and just make it a little bit more general and just make it like a safety critical operation. Now, we always need to be doing something, so there's like a minimum cognitive load that we have, which is the whatever operation or task we're currently involved in. But by definition, this task is a safety critical operation, which usually means we need to keep consuming information about the environment that we're currently in, that is maintaining a high level of situational awareness. But every bit of information that we consume to maintain that situational awareness takes away from our cognitive capacity, and we don't want to end up overloading that cognitive capacity because we then can't do anything. On the other extreme, we can't just not give information to the user while they're doing this dangerous operation, because that means zero situational awareness, and that's super unsafe as well. So they have maximum cognitive capacity available, but that's not going to be very useful because they don't know what's going on. Now, just as we discussed about the balancing act with maintaining graphical fidelity last week, maintaining situational awareness is also a bit of a balancing act. Okay, let's switch it up a bit. So I talked about a situation where we could easily become overloaded. You're in the cockpit, you're looking out for other aircraft, you're looking at your instruments, and you're also listening out for the radio. That's a lot of things that you need to keep track of the whole time. But basically, too much information, bad. But what about the opposite side? What if we didn't have enough information? What if we were sitting in a forklift somewhere in a warehouse? There's metal grinders, there's a plasma CNC machine, there's a huge massive sculpture right in front of you, there's a bunch of 20-year-olds going around the place pretending to be artists and engineers or whatever it is they're doing, but you're sitting on the ground. It's kind of relaxing almost. No aircraft engine blaring outside, there's no one on the radio telling you to do anything, and there's no risk, or there's nothing else that's kind of moving that could actually hurt you. So you're fine in your big, massive forklift thing. But in this situation, you're the one who might actually be able to hurt other people, especially if you're just all relaxed and not paying attention. Now, you probably would start paying attention if you heard like a really, really loud scream, but at that stage it's probably already too late. So we need some other things to help us pay attention. And you've seen all this already, most probably. So if you're in a factory or something, or maybe some of you have had a chance to help set up in an anime or a gaming conference, you'll have these things called bump-ins. Health and safety always gets you to wear high-vis, highly reflective clothing. So that's just basically to give people who are driving these dangerous machines a little bit of help to actually see you. You know, like before someone gets run over and has to scream. Speaking of screams, sound is also a really good way to enhance situational awareness. If we take the typical reverse beeping sound example, that's a really insightful thing to break down. So let's say there's a truck, it's reversing back into a loading bay, and it's going beep, 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 beep. We know that sound, right? And let's break that down. So the first thing to notice about that sound is it's really annoying and unusual. So it's something that we pay attention to because it's not something that's in the background. Then the other thing is it's coming from the object that's actually moving, that's dangerous. So just from its very positioning, we can kind of already tell where it's coming from just by the source of the audio. So it's a very simple solution that actually integrates a lot of cool situational awareness considerations. We can get even more blunt with our sound tools, sound instruments. So let's take our typical air horn. Now, air horns feature in some pretty cool joke videos on YouTube, but they also have a very serious purpose to them. So it's super loud, and I guess the idea with that is to get someone's attention to something important that's happening. So where it's most useful, I guess, is when there's a lot of noise around the place, like say in a construction area, and you want everyone in that space to pay attention to you. But it's a fairly blunt instrument. It can only really give out one signal, which is the one loud noise. If we contrast this to megaphone announcements have a little bit more resolution to them in that you can hear someone speak. There could be extra information in the speech telling you that, a crane's about to start lifting things, or it's transporting something across the workspace and you need to stay clear or watch out. Concrete pourer coming in overhead, or something like that. This is just what I imagine. I've never actually been to a construction site, but I've lived across one for a whole year, so this is the kind of thing you would hear in the megaphone. It's actually more annoying than the actual banging and construction-y type sounds. But that's the point of it, right? You're trying to get attention from someone, so if it is unusual and it is surprising and annoying, it actually gets the job done. So I chose these particular examples to talk about because they're fairly typical, but you can also see the varying aspects to them. It's good to break down their specific properties and what they're good for in what particular situation, because there's not just one silver bullet kind of thing. You will often find that you're mixing and matching all sorts of different schemes. Again, let's take the construction site example. If we have a lot of noise in terms of the tools, jackhammers and drills and things like that happening in the background, that just all becomes white noise to everyone in the site, right? And if you wanted to make an announcement to the megaphone, there's a risk that that might just be included in the white noise sound, so that's not going to be effective. So you combine that with the air horn that's louder than everything else. People pay attention, and then gets quiet a little bit, and everyone looks at the air horn guy, and then you start the megaphone announcement. Again, this is just how I imagine that situation would actually play out. This course isn't Construction Site Management 101. Really what I'm trying to attempt to do here is break down what information is available in these particular signals that we're giving to people, and in which situations they might be effective and useful. But let's keep in mind that we're not the domain experts in this area, unless we actually are. Like I'm not a construction builder person. So it's always good to consult the domain experts in this area and then fuse their knowledge with our human-centered immersive design principles. Anyway, this slide is basically about attention seekers, attention getters. But if we use these signals too often, we risk turning them into white noise, or worse, we risk overloading people and they end up not being able to operate at all. And so it's useful to consider things that reduce workload, but reduce it in a way that it's not actually taking more information away. So like the obvious way of reducing workload or reducing noise is to just not make that noise. But sometimes that noise is really important information. So the problem here is to work out some way to keep the same amount of information but not have it costing so much cognitive capacity from the user. And I'll just briefly mention two nice things. First one is ecological interface design. The theoretical basis for this was really solidified back in the 80s and 90s, but hints of this actually have come out much earlier than that, specifically in aviation. I like using the aviation example because aviation's cool, and why wouldn't you? But it's also quite representative of what ecological interface design is about. And if we just take the example of grouping related instruments together on your instrument panel, That's really simple to understand. But if you break it down, it actually does a lot in reducing your workload. It doesn't make sense to have your artificial horizon on one side of the dashboard and then you have your altitude on the other side, and then you've got to look, really far away to actually see what's happening, because very often you will want to know the status of both pretty much at the same time. To simplify it further, if you're a pilot and you're in cloud and you can't see outside the window, you will want to know how high you are, and you'll also want to know the orientation of your aeroplane, whether it's like upside down or going up or slowly going down. Like, that's really critical information you want to know at the same time. In terms of actually manufacturing the dashboard, it doesn't cost anything to actually put these two instruments together, but it helps so much. Next thing I wanted to just quickly touch on is cognitive fit theory, and this is kind of related to ecological interface design, but it's much more fundamental. And cognitive fit theory basically postulates that there are optimal ways of presenting certain types of information. Most of the literature that you'll see in this space would be looking at static representations of information. So you might be looking at financial data through graphs or tables with numbers. The idea there is still quite profound, and it's something applicable to us in immersive design. So when we're visualizing information, we need to think about whether it's actually the right way of displaying that information. I guess it depends on your particular design goal, but let's just assume our goal is to reduce the quote-unquote cognitive cost of the information that we're trying to display and maximize situational awareness. You'll need to think about questions like, is it actually okay to display a bunch of information using alphanumeric text? Could you possibly make that more consumable if you were to represent that using colors or different kinds of visualizations? I don't know, the specifics you'll really need to look into, and to be honest with you, cognitive load theory still has a lot of scope to grow, and there's a lot of contribution yet to be made, so we know more about how people perceive things and what the cognitive costs of each kind of representation is and in what situation. But it's still good to keep this in mind when applying immersive design principles, especially in these safety critical situations. Because if you can prevent accidents by applying good human-centric design, why not? We've won. We've saved someone's life by thinking about things a little bit more, and that's always a good thing, right? Okay, so let's try and wrap this up a little bit. And this obviously is a super complex area, but we can come up with a few guidelines if we just think back to the fundamental issue of overloading the user with too much information, but on the other hand also making sure that we don't withhold too much information. We can basically just say maybe we should display the most pertinent information. But you know what, that's super easy to say. We don't actually know what the most pertinent information is. It's very domain specific, right? Aviation, like, there's very specific bits of information that you want to know at certain times. But that's also very different in the construction domain too. So the key thing here really is to consult the domain experts, and then we can then just apply, like I said, we can apply our immersive design knowledge to that specific area, which again presents its own problem because that requires a certain level of communication, and we don't always speak the same language. We can deal with this in week 7. That's where we'll be talking about immersive design teams. I guess we'll also talk a little bit about it in week 9, where we cover evaluation and compliance. But anyway, just wrapping this particular guideline up. Display the information that's needed the most, leave out the junk because you don't want to overload people, and I guess also use the most efficient method of displaying that particular type of information. We also have some quote-unquote quick hints or quick picks perceptually. One favorite one that I have, which ties into last week's topic, is flashing lights. So We learned last week that our peripheral vision is pretty low resolution, but it's actually quite sensitive to motion or things that change over time. So flashing lights is something really effective that we would be able to perceive even at our peripheries. That's why it's used so often with heavy machinery like cranes and forklifts and things like that, because even people not really paying attention will be forced to pay attention. Similar sort of idea with audio alerts. We've talked about that in some detail already, but I just wanted to add that our audio system is actually parallel to our visual systems, and this is how people have discovered this thing called the multimodal effect. And the way I understand that effect is adding extra auditory information in your environment doesn't actually take away from any budget from your visual perception. So you can think of them almost as two different piles of cognitive budgets, and anything that you put on the visual budget doesn't take away from the audio budget, so you might as well use them all up. It's probably a pretty sinister way of putting it, but one way I've seen this manifest itself is if I'm already busy doing something else in the cockpit, I can ask my co-pilot to do something else, and asking them to do something else doesn't actually cost me anything extra. A more everyday example of this would probably be if you're talking to one of your passengers while you're driving and you're actually not crashing the car. Next point, we should make our alerts rare so people don't start ignoring them. And this is essentially why alerts actually work. From an evolutionary standpoint, you could say that it's actually surprises and unusual events that give us alerts and make us pay attention. Because we're receiving information all the time in our senses, right? But if it just happens too often, it becomes white noise and we feel safe. But if there's something that's unusual, that possibly represents some kind of change in the environment, and it might even be dangerous. So that's why we can't not pay attention, because we're just wired to do that. You don't want to counteract that wiring by making your alerts white noise, so it's actually our fault if we spam alerts too much. We can't blame people for not paying attention to the alerts. So we talked about this topic for almost half an hour now. Maybe when you go away a bit later, I'll challenge you to try and think about more guidelines based on some of these principles that we've covered. Now, this doesn't really leave us much time to talk about the other stuff, namely accurate training for safety critical situations, the therapeutic applications, and well-being applications. But I don't feel too bad. All of them are really just based on the principles that we talked about earlier, mostly. And in the case of training, that gets covered in another unit, DDES 9911, but I will attempt to encapsulate it in just a few sentences. Essentially, when we're training someone to do something in real life and that particular task is actually safety critical, you really want to make sure that you're training them for that particular task in the right way. And that means focusing on the right thing and also not giving opportunity to create bad habits. Focusing on the right thing to me just means that you don't spend a lot of time making sure that the water graphics and the terrain graphics are really nice when what you actually want to be training the people on is how to operate a winch on a helicopter. So that's you want to concentrate all your fidelity and all your effort in making that representation correct. That is the operation of the winch. You'll also see this in flight simulators. This is why you often see the actual instruments and the other hardware that's actually used on the aircraft, so you retain that muscle memory. One of the things that I really remember from visiting the ACE training center was the head of the facility, who was also a helicopter pilot, emphasized the location of the collective. That's the lever that controls the height of the helicopter, whether it goes up and down. Yeah, I mean, it's just something as simple as making sure it's on the right side of the pilot. It is actually really important. And you'd think it's something simple and stupid, but in emergency situations, muscle memory is a real thing, and that's what you're trying to develop in the simulator. Okay, next slide, therapeutic applications. We're really running out of time, so I'm only just going to say a few words about this, but we have a couple of readings if you want to go into more detail. But the key thing really to take a look at this is we're using the power of immersion and the power of presence to be able to make exposure therapy a lot more effective. Exposure therapy by its very nature is already safe. You're in a controlled environment. You're gradually exposing someone to what they're afraid of in incrementally higher and higher levels until they get to a point where they're sufficiently not afraid of that thing anymore to be able to function properly around it. What immersive design gives us is something extra than just showing someone a photo of a spider or getting them to touch a spider toy. At the same time, it also gives us slightly more control than actually exposing someone to a real spider, like either behind glass or something like that. We have logistical benefits in using virtual spiders. We don't have to catch the spider, and there's also zero risk of the spider jumping out of whatever enclosure you have it in and scaring the patient to death or something like that. But I'm probably already preaching to the converted here. I just really wanted to point out that we are so useful that we can actually be used in these traditional fields, and we actually help and enhance it as immersive designers, I mean. And it's so effective that it's actually being used in something so serious as PTSD treatment and exposure therapy. And it's not just about serious psychological interventions, it's also softer things like soft skills training. You can't get any softer than that because it has soft in the name. But let's just quickly take a look at patient interaction and implicit bias training. The advantage of using immersive design in those two situations is you don't really want to be making mistakes while you're dealing with a patient. You might end up making things worse and traumatizing them further. Or in a more subtle way, you might just be perpetrating some kind of aggression towards a coworker even though you didn't actually want to, because you still haven't dealt with all these implicit biases that you have. It's not great to learn these things with real people, so you would be better off doing it in the simulation. But it's still pretty expensive to use actors, so it might be useful to do this in a virtual setting. But anyway, it's good to be aware of the fact that these are actually real things that immersive design is being applied to at the moment, and perhaps you have a contribution to make in that area if you want to. And that's it. We're a little bit over time. I hope that's plenty of discussion points for us to start talking about in the tutorial class. So see you in class.